This lecture was created by Danny Kessler, Associate Professor at Dongsa University and Korea's first PhD in wellness tourism. Modern clinical architecture follows a specific hierarchy. Hospitals are engineered to maximize the efficiency of the doctors and nurses who navigate them while standing. This orientation prioritizes the workflow of the professional, leaving the sensory experience of the patient as an unaddressed variable in the design. We focus instead on the horizontal human, the individual in recovery whose entire environment is viewed from a supine position. Because standard hospitals ignore this perspective, the architectural choices in these spaces frequently trigger acute stress responses in the very people they are meant to heal. To many medical professionals, a hospital building is a static container, a place where medicine is administered without the walls themselves affecting the outcome. In reality, every physical surface and light source acts as a biological input, transmitting a constant stream of sensory data to the brain. Standard clinical settings provide specific inputs, such as rapidly fluctuating temperatures, high-frequency artificial light sources, and surfaces that amplify noise. The autonomic nervous system processes these inputs as indicators of instability, shifting the body into a state of physiological vigilance. We are exploring how to reverse engineer these environments to intentionally signal safety to the brain and initiate the recovery process. The built environment determines the baseline physiological state of the human occupant. Finnish architect 𝗨𝗨𝗏 began investigating these biological connections in the early 20th century. His 1933 design for the 𝗵𝗄 Sanitarium served as a primary test case for architecture as an active intervention. 𝗨𝗏 approached the design with the belief that the building must function as a medical instrument. He realized that for physical healing to occur, the architecture had to first regulate the patient's nervous system through light, air, and silence. He addressed noise by redesigning the geometry of standard fixtures. By angling water to hit the wash basin at exactly 45 degrees, he removed the splashing sounds that cause startle responses in resting patients. These acoustic adjustments reduced the amount of external environmental noise the brain had to process. 𝗨𝗏 also integrated soft ceiling colors to lower visual stimulation for those confined to a bed. The building assumed the work of nervous system regulation, allowing the patient to focus their biological energy on recovery. This integration of architectural design and brain science is now classified as neuroarchitecture. The field focuses on how specific ambient inputs, such as sound profiles and light levels, can be used to manually trigger the body's internal repair mechanisms. When successful, these inputs activate the parasympathetic response, the physiological state required for rest and cellular maintenance. This is the biological opposite of the sympathetic response, the fight or flight state maintained by the stress of traditional institutional design. When the environment is controlled to eliminate perceived threats, the brain stops diverting energy toward monitoring its surroundings. Architecture can be used to bypass a patient's stress response and facilitate a state of rest. These principles align with servicescape theory, which suggests that physical settings dictate human social behavior. We see a clear application of this in the traditional Korean ondol system. This underfloor heating technology serves as a social neurointervention in the modern 𝗔𝗀𝗏𝗃. Research by 𝗏 in 2023 shows that radiant floor heat signals safety to the nervous system, creating a subconscious sense of home. This thermal signal correlates with a decrease in social cortisol levels and a reduction in defensive postures. In a standard gray corridor, individuals remain guarded. In a warm, radiant environment, those same people relax. By utilizing the floor as a thermal heat source, the space allows strangers to interact as if they were in a private residence. Adjusting the floor temperature alone can reduce social isolation and encourage coworker intimacy. These clinical and social examples are now forming the basis for wellness real estate. This design approach moves away from building spaces that only react to disease. The shift is toward longevity architecture. The goal of these spaces is to maintain the biological health of the occupant on a daily basis. Success in this field requires prioritizing the horizontal and sensory experience of the user over traditional visual aesthetics. Modern architecture is increasingly measured by its ability to support human biological needs. There is a practical limit to this science. While these interventions are effective in new construction, they are difficult to implement in legacy buildings. Older university campuses and hospitals possess geometric and spatial constraints that make retrofitting for sensory health a significant challenge. Look at the room where you are sitting or lying down right now. Is the architecture of your current environment causing your body to maintain a state of stress? Does the space around you provide the conditions necessary for your body to heal? Every room acts as a neurological intervention, altering the chemistry of the body whether the architect intended it or not. This lecture was created by Danny Kessler, Associate Professor at Dongseo University and Korea's first PhD in wellness tourism. Thank you for listening.